Okay, so today we're going to be doing multiplying matrices. So I'm going to show you how to multiply two matrices. All right, so first of all, let's take a look at example one. So let's determine how do we know if we can multiply two matrices or not. All right, so we're going to determine whether the product of two matrices is defined or undefined. In order to do that, you want to take a look at the dimensions of the two matrices that you are trying to multiply. So for example A, we have, let's see, can I change the size? Yes, here we go. All right, let's change the size. That's kind of big. Okay, so they tell us that matrix A is a 3 by 4 and matrix B is a 2 by 4. All right, so in order to multiply two matrices, you want to look at the columns of the first matrix and the rows of the second matrix. All right, in order to multiply them, they have to have the same number of columns in the first matrix and the same number of rows in the second matrix in order to be able to multiply them. So if you write out the dimensions side by side, you want to check to make sure the two numbers that are in the middle are going to be the same. So matrix A has 4 columns, matrix B has 2 rows. So those numbers don't match. So because those numbers don't match, this product is undefined. All right, so let's bring this down to 12-point font. And I'm going to make that a little bit smaller. Okay. So for part A, so because the number of columns in matrix A, which matrix A has 4 columns, does not match the number of rows. Okay. Oh, I was a little early. So does not equal. Okay. Does not equal the number of rows it's moving all over the place here. All right, let's go back up. All right, so because the number of columns in matrix A, which has 4, does not equal the number of rows in part B, in which the number of rows in part B is 2, the product AB is undefined. I'm going to make that a little smaller. Okay, so again, you want to write your dimensions out side by side. So matrix A was a 3 by 4, matrix B was a 2 by 4. You want to check, make sure the numbers in the middle match. So this one is a 4, this one is a 2. They are not the same. Therefore, the product is undefined. All right, so now let's look at the second matrix, the second problem. So it says matrix A has 3 rows, 4 columns. Matrix B has 4 rows, 3 columns. All right, so those two numbers that are in the middle, they match. All right, so because they are the same, that means the product is defined. Okay, so that product is defined, and in order to get the size of your new matrix, the numbers that you have on the outside, all right, will be your new size. So that means my answer matrix, my product, is going to be a 3 by 3 matrix. Okay, so Again, write the dimensions side by side. So the first matrix is a 3 by 4. Second matrix is a 4 by 3. All right, you check to make sure those two numbers in the middle are the same. If they are, then the product is defined, and your answer will be the size of whatever numbers are on the outside. So in this particular case, it's a 3 row by 3 column matrix to be the answer. All right, so that's how you determine if you can even multiply two matrices. All right, so now we're going to talk about how do you actually multiply them. All right, so let's take a look at the next example. Okay, so it says find AB if A equals 2, 1, negative 3, 4, 5, negative 2, and B equals 3, negative 2, negative 1, 5. All right, so when you multiply matrices, you multiply rows in the first matrix by columns in the second matrix. All right, so you're going to multiply each row by each column, okay? So, of course, I'm going to start with the first row. So I'm going to multiply this first row here. And that is kind of thick, so let's erase and try that again. Okay, it is red. Just making sure. All right, so I'm going to multiply this first row here by this first column. Okay, so whenever you do this, you match the first number, okay, with the first number here. All right, so the first number of the row is going to match with the first number of the column. So those are the first two numbers that I'm going to multiply. So I'm going to do 2 times 3. All right, and then I'm going to match the second number of the row with the second number of the column. All right, so then next I'm going to multiply those two numbers. So it'll be 1 times negative 1. All right, and so once you multiply those two sets of numbers, then you will add those products together. So you're going to get 2 times 3 plus 1 times negative 1. All right, so that takes care of the first row by the second column. So once you multiply that first row by the second column, first row by the first column, that's going to be the very first entry, all right, in your answer matrix. So next thing you want to do is repeat those steps with the first row, but now you're going to multiply the first row by the second column because we have to do each row by each column. All right, and so now that answer choice is going to go on the first row and the second column of my answer. Okay, so again, same thing like I did the first time, the first number. All right, so this 2 here, okay, is going to match with the first number of the second column. So that's going to be 2 times negative 2. All right, and then the second number of my row is going to match with the second number of my column. So it's going to be 1 times 5. All right, and so we have the first row, which is the first row, second column entry. All right, so now we move on to the next row. I'm going to pick a different color here. All right, so second row, which is negative 3, 4. All right, now I'm going to multiply this row by each column. So start with the first column, of course. And again, you match the first number of the row with the first number of the column. So that's going to be negative 3 times positive 3. All right, and then now I'm going to match the second number of the row by the second number of the column. So 4 and negative 1. Again, after you get those two products, you'll add them together Okay, and that's going to give you the second row, first column entry of your answer. All right, and so now I'm going to repeat those steps again, but this time it's going to be with the second column. So second row times the second column. Okay, so again, first entry of the row by first entry of the column. So -3 and -2. And then second entry of the row by the second entry of the column. So 4 times 5. And again, once you get those two products, then you would add them together. Okay, so now we move on to the last row. So that's going to be 5, -2. All right, so it's going to be 5, -2 times the first row. So again, first entry of the row by the first entry of the column. So 5 times 3. All right, and then second entry of the row times the second entry of the column. So that would be -2 times -1. All right, and notice this time they did not put a plus sign here. That's because this was -2. So they just simplified the signs. Okay, so instead of writing plus -2 times -1, they just changed the sign to a negative sign. Okay, it's totally up to you whether you prefer to write both signs and then simplify later or to simplify your signs at one time. Okay, and I'm going to now use a pretty pink. Okay, so now we're going to do last row by the last column. And so this is going to give us our third row, second column entry. Okay, so first entry times the first entry, so 5 and -2. And then second entry times second entry, which is -2 times 5. So again, they did the same thing here. They simplified the signs. Instead of writing plus -2 times 5, they just wrote -2 times 5. All right, so now once I have written out all my products, now I'm going to actually simplify it. You can simplify it all in one step, or you can break it down into 2. It's up to you. I'm going to break it down into 2 steps. All right, so I'm going to multiply my products first. So 2 times 3 would give me 6. And then +1 times a -1 is going to give me a -1. 2 times -2 gives me -4. And then 1 times 5 is a +5. All right, -3 times 3 is a -9. And then 4 times -1 is going to give me a -4. -3 times -2 is a +6. 4 times 5 is a +9. 5 times 3 is 15. And then -2 times -1 becomes +2. 5 times -2 is -10. And then -2 times 5 is also -10. Right? And so now the last thing to do is to find your sums. So 6 and -1 gives me 5. -9, -4 would give me -13. Let's see. Let me extend that out just a little bit. Okay, just a little bit. So 15 and 2 would give me 17. -4 and 5 is 1. 6 and 9 is 15. And then -10 and -10 is -20. All right, and then that would be my product of my matrix. All right, and I just realized I did skip a step, and that was to verify that I could actually do this. And I kind of didn't do it just because the example was already laid out, but I'm gonna go back and do it. So to determine if I would have been able to multiply these two matrices, I would have written out my dimensions of the first matrix and the second matrix. So since it was A times B, I would of course write the dimensions of A first. So A is a 1, 2, 3 row by 1, 2 column matrix. And then matrix B is a 1, 2, so 2 row by 1, 2 column matrix. All right, so again, these two numbers in the middle match. All right, so that means I can actually multiply those two. And then my final answer should be a 3 row by 2 column matrix. And it is. So I have 1, 2, 3 rows, 1, 2 columns. So, yep. Granted that all my math is correct, I did it right. Okay, so that's how you multiply matrices. We're going to move on to another example just so you can get another example of being able to multiply matrices. All right, so here's the checkpoint. So it says given A and B, give the dimensions of AB, then give AB. All right, so give the product of AB. So first we're going to find the dimensions of what AB would be. So in order to do that, okay, we're going to write out the dimensions. So it's A times B. So A is first, so I'm going to write out the dimensions of A first. So this would be a 2 row, 1, 2, by 2 column matrix, 1, 2. Dimensions of B, 1, 2 rows by 1, 2 columns. All right, so again, I'm going to check the numbers in the middle. All right, they match. So that means, yes, I can multiply these two products, well, these two matrices to make a product. All right, and then my answer, my dimensions would be what numbers are on the outside. So 2 rows, 2 columns. All right, so the dimensions of AB are going to be 2 by 2. All right, so now that I've determined what the dimensions will be, next I want to find the product of A times B. All right, so let's go ahead and do that. Okay, so I'm going to start with the first row again. First row, all right, by the first column. So that's going to give me the first entry of the row by the first entry of the column. So that'll be 1 times 2. All right, then I would add that to the product of the second entry. So second entry of the row, second entry of the column. So that would be 0 times 3. Okay. And so far, we've only done this with 2 row 2 by 2 column multiplications. But if there was a third row, all right, then I would just add the product of the third elements multiplied. All right, and I would continue on. So if there was a fourth row and a fourth column, then I would add again and do the product of those. So basically, if it continues with rows and columns, you just keep going and you keep adding them together. All right, so that takes care of the first row and the second column. So now I'm going to do first row by the second column. So first row, second column. So first entry again by the first entry here. So there's going to be 1 times -1 plus, right? And then second entry by the second entry. So 0 by 0, 0 times 0. Okay. Now I'm going to move to the next row. So next row, which would be 2, -3 by the first column. So first entry by first entry. So 2 times 2 plus second entry, and second entry. So negative 3 times 3. And last one. So last row by the last column. So first entry by first entry. So 2 and negative 1. Plus, and then I would do the second entry by the second entry. So negative 3 and 0. Down the middle. All right, so let's go ahead and simplify. So 2 times 1 would give me 2. 0 times 3 is 0. 1 times negative 1 is negative 1. 0 times 0 is 0. 2 times 2 is 4. Negative 3 times 3 is negative 9. 2 times negative 1 is negative 2. And negative 3 times 0 is 0. So found those products, and then I can find my sums. So 2 plus 0 is 2. Negative 1 plus 0 is negative 1. 4 minus 9 is negative 5. And then negative 2 plus 0 is negative 2. All right, and the reason why this one is negative is because I got a negative product up here. So instead of writing plus negative 9, I just simplified the signs to negative 9. All right, and then this will be my final answer. All right, and the answer should have been a 2 by 2 matrix, and it is. It has 2 rows and 2 columns. Okay, so that is how you multiply 2 matrices. All right, so for example 3 is still multiplying matrices. Only thing is they are doing matrices, they're multiplying it forwards and backwards. And something interesting happens usually if you multiply 2 numbers. All right, but multiplication is usually commutative. So that means if I multiply 2 times 3, I should get the same thing if I multiply the 3 first times 2. All right. However, matrix multiplication is not that way. All right. So just because I get one answer for A times B does not necessarily mean I will get that same answer for B times A. So we're going to do that for example 3. So they give us the matrix A, which is negative 2, 4, 0, 3. And they give us the matrix B, which is 2, 1, 4, negative 3. And then they ask us to find the product of AB forwards. And then they ask us to find it backwards with B times A. All right, so I'm just going to go ahead and do this. So again, I'm not going to do all of the colors like I have been doing, but I am going to show you how to match them still. All right, so the first entry of the first row by the first entry of the first column. So that would give me negative 2 times 2. All right, and then I would add that to the product of the second entry of each row / column. So 4 times 4. All right, and then I'm going to move on first row times the second column. So that's going to give me negative 2 times 1 plus, and then second entry times second entry here. So 4 times negative 3. All right, now I'm going to move to the second row. So again, first entry of the second row times the first entry of the first column. So that will give me 0 times 2 plus, and then I'm going to do the next one, 3 times 4. And then the last row and column, so 0 and 1 plus 3 times negative 3. Okay, now I'm going to simplify it. Now, I have been doing product then addition. I'm just going to go ahead and do it all in one swoop this time. So negative 2 times 2 is negative 4. 4 times 4 is 16. So negative 4 plus 16 is going to be positive 12. Negative 2 times 1 is negative 2. 4 times negative 3 is negative 12. Negative 2 plus negative 12 is negative 14. 0 times 2 is 0. 3 times 4 is 12. 0 plus 12 is 12. 0 times 1 is 0. 3 times negative 3 is negative 9. So 0 minus negative 9 is negative 9. Okay, and so that would be the answer for A times B. Okay, matrix 12, negative 14, 12, negative 9. All right, so now I'm going to do it backwards, and now I'm going to do B times A. All right, so again, first row by the first column. So first entry matches with the first entry here. So that's 2 times negative 2 plus, and then I'm going to do the second entry by the second entry. So 1 times 0. All right, then I move to the first row to the second column. So 2 times 4 plus second entry, which is 1 times 3. All right, now moving on to the last row. So 4, negative 2 plus, okay, second entry, that was supposed to be a square, sorry. All right, so negative 3 times 0. All right, and then last row and column, so 4 and 4, which is 4 plus negative 3 and 3. Okay, so now let's simplify this and see what we get. So 2 times negative 2 is negative 4 plus 1 times 0, which is 0. So negative 4 and 0 is negative 4. 2 times 4 is 8 plus 1 times 3, which is 3. So 8 plus 3 is 11. 4 times negative 2 is negative 8. Negative 3 times 0 is 0. Negative 8 and 0 is negative 8. All right, and then 4 times 4, which is 16. Negative 3 times 3 is negative 9. 16 and negative 9 is 7. All right, so notice here, AB does not equal BA. All right, those entries for both matrices are not the same. All right, so matrix multiplication is not commutative. All right, and I'm just going to type that on the side. All right, so you can just put that as a little note on the side. Matrix multiplication is not commutative. Okay, so using matrix operations. So this is going to be sort of like order of operations, but using matrices. So order of operations, that's PEMDAS. Okay, just a refresher of what that is. Order of operations. So PEMDAS, which means parentheses first, exponent second, all right, multiplication slash division. Of course, they go together, so you would do both of them, left to right, whichever comes first. So multiplication doesn't necessarily have to be in the beginning. Okay, if division comes before multiplication, then you would do division first. They just go together. And then, of course, addition and subtraction. So same thing like multiplication and division, whichever one comes first, subtraction or addition, it does not matter. They are done at the same time. All right, so PEMDAS still works with matrix operations. All right, it's just that you have to perform the correct matrix operation. So let's look at the examples that they have. So it says they give us the matrix for A, B, and they give us a matrix for C. It says simplify each expression, A plus B times C. All right, so I am going to go ahead and write that out. What that means. Oh, and they've already done it. So they've started it for me. All right, so down here. So they've started it. All right, so A plus B times C. All right, so of course, order of operations tells me I should do what's in the parentheses first. All right, so the parentheses says A plus B. So that means I'm going to add matrix A plus matrix B first before I do anything. Okay, so I'm going to do 3 plus 2. Right? Because remember, you add the entries that are corresponding. So the entries that are in the same exact spot on both matrices. So 3 and 2 are both entry 1, 1. So I'm going to add those two together. So 3 plus 2 will give me 5. All right, and then I'm going to add 1 and 1. So 1 plus 1 will give me 2. All right, and then negative 2 and 0 correspond. So negative 2 and 0 is negative 2. And 1. Negative 1 here matches with the negative 3. So negative 1 and negative 3 would give me negative 4. All right, so after I add those two matrices together, then I would do my multiplication. All right, and so both of them are a 2 by 2 matrix, so I can multiply them. And this is what I would get. All right, so first entry times first entry. So 5 times 4 is 20. All right, that's going to be plus 2 times negative 3, which is negative 6. Then I'm going to do 5 times 2, which is 10. And then 2 times 2, that's positive 4. All right, negative 2 times negative 3, that's a positive 6. I'm sorry, I multiplied the wrong thing just now. All right, so I was supposed to do negative 2 times positive 4. Okay, so I messed up here. I was supposed to do the first entry times the first entry up here. So negative 2 times 4 is negative 8. Glad I caught that before I kept going. Plus negative 4 times negative 3, which is a positive 12. All right, and then negative 2 times positive 2, which is negative 4. Plus negative 4 times negative 2, positive 2, which is a negative 8. All right, then of course I'm going to simplify those. So 20 and negative 6 is going to be a positive 14. 10 and 4 is a positive 14. Negative 8 and 12 is going to be positive 4. And then negative 4, negative 8 is a negative 12. All right, and so that would be the answer. So I just basically follow my rules of matrix operations as well as my rules of order of operations. Parentheses first, so I added them together. And then after I added them, then I was able to multiply them. All right, so now let's take a look at B. All right, so B says AC plus BC. All right, so in this particular case of order of operations, all right, there are no parentheses, there are no exponents. However, there is multiplication. All right, so that means I'm going to do the multiplication first. So that means I'm going to multiply A times C, and I'm going to multiply B times C. Doesn't matter which one you do first. You technically kind of can do them at the same time. I'm going to, since there's not enough space here, I'm going to write it off to the side. So let's see, AC equals. All right, so multiply A times C. So 3 times 4 would give me 12. And then I will do 1 times negative 3, which is negative 3. All right, then I'm going to do 3 times 2, which is 6. And then 1 times 2, which is positive 2. All right, then the next row, so negative 2 and 4 is negative 8. And then negative 1 times negative 3 is a positive 3. And then negative 2 times 2, which is negative 4. And then negative 1 times 2 is negative 2. And then I'm going to simplify this really quickly. So 12 minus 3 is 9. 6 and 2 is 8. Negative 8 and 3 is negative 5. And then negative 4, negative 2 is negative 6. All right, so I can replace this A times C with 9, 8, negative 5, negative 6. All right, so now I'm going to do the next one, which is BC. So BC equals, all right, so I will do 2 times 4, which is 8, plus 1 times negative 3, which is negative 3. And then I'm going to do the next column, so 2 times 2, which is 4. 1 times 2, which is positive 2. All right, so now I'm on to the second row. So 0 times 4, which is 0. Negative 3 times negative 3, which is positive 9. All right, and then last row, last column, 0 times 2, which is 0. And then negative 3 times 2, which is negative 6. All right, so negative 6. Okay, and then I can simplify that. 8 minus 3 is positive 5. 4 and 2 is positive 6. 0 and 9 is positive 9. And then 0 and negative 6 is negative 6. All right, so I'm going to replace that there with 5, 6, 9, and negative 6. All right, so now that I've taken care of my multiplication, now I can go ahead and perform the addition. So 9 plus 5 is going to be 14. 8 plus 6 is going to be 14. All right, negative 5 plus 9 is going to be 4. And negative 6 plus negative 6 is negative 12. All right, so notice here, both of these are the same. All right, so what is happening here is called distributive property. All right, so remember with distributive property, I'm not going to write this, I'm going to go ahead and type it. Okay, so with distributive property, all right, we knew that if we multiplied A times B plus C, all right, that would give me, I can distribute the A to both the B and the C. So that would give me AB plus BC. All right, so what you need to know is that distributive property is true for matrix multiplication. All right, so even though matrix multiplication is not commutative, here with matrix multiplication, distributive property does still work. All right, so not commutative, but you can still perform distributive property. All right, so that is going to be all of the notes on matrix multiplication. Thank you so much for watching my video.